Bismillah ar-Rahman ar-Rahim. We continue doing questions from the book. Now we're almost done with the 3x3 matrices. This will be the last one. Then I will do some 4x4 matrices. Yeah. Let me do this one. No, I mean this one, 2x2. So I need to find A minus lambda I. That will be what? That will be 2 minus lambda minus 2, 1, minus 1, 2 minus lambda, 0, minus 5, 7, minus 1, minus lambda. I'll do the expansion with the last column, with this column. So I have what? I have 1. I cancel the first row and the second and the last column. I have minus 1, 2 minus lambda, minus 5 and 7. And do the last one, minus 1 minus lambda, times the remaining first, third column, third row. So I have 2 minus lambda minus 2, minus 1, 2 minus lambda. Let me do the calculation. I have what? Minus 7 plus 10 plus 5, minus 5 lambda. That's minus, 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 so it will be minus 5 lambda. Okay. Plus minus 1 minus lambda times what? I have here. What is this? This is 2 minus lambda square, which is lambda square, minus 4 lambda, plus 4, minus 2. That is 2. Do the calculation. I have but minus 5 lambda, plus 3. Okay, plus what? Minus lambda cubed. What will bring the square? 4 lambda square minus lambda square. That will be plus minus 4 lambda square. That will be plus 3 lambda square. Okay. Then I have what? Minus 2 lambda plus 4 lambda plus 2 lambda minus 2. The last is 2 times minus 1. That will be minus 2. So what I have? Minus lambda cubed plus 3 lambda square minus 3 lambda plus 1. Take minus common factor. I have lambda cubed minus 3 lambda square plus 3 lambda minus 1. Now I can do it. Take lambda cube with minus 1 and take minus 3 lambda with the rest. I have lambda minus 1. So this is minus. I have lambda minus 1, difference of 2 cubes. Minus 3 lambda, lambda minus 1. That will be minus. Can take lambda minus 1 common factor. I have lambda square minus 2 lambda plus 1. That will be minus lambda minus 1, lambda minus 1 square. Okay, simply 1 lambda. So the eigenvalues, lambda 1, 1, 1, repeated 3 times. Now let me try to find the eigenvectors. Yeah. So for lambda equal 1, actually I have only 1 lambda. See how many eigenvectors I should have. If I have 3, then diagonalizable, otherwise it's not diagonalizable. Okay, let me substitute what I will have. 2 minus 1, that will be 1, minus 2, 1, minus 1, 1, 0, minus 5, 7, minus 2, times K1, K2, K3, equals 0, 0, 0. I need to solve for the case. So I have what? K1 minus 2, K2 plus K3 equals 0. I have minus K1 plus K2 equals 0. I have minus 5K1 plus 7K2 minus 2K3 equals 0. So from here, I have K1 equal K2. Plug it there and there. You have what? K3 minus K1 minus K2 equals, if I plug K1, I have K2 minus 2K2, that will be minus K2. Plug it here, I have minus 5K2 plus 2K plus 7K2, that will be 2K2 minus 2K3 equals 0. So these two equations, they have K3 equal K2 also. So K2 is my free variable, K2 equal 1. I have K1 equal K3 equals 1. So I will one vector, 1, 1, 1. So A is not diagonalizable. Actually, it has only one eigenvector. This is 1, 1, 1. Now it will go to the 4 by 4. But they are 4 by 4, but I think they will be quick. I have A minus lambda I. That will be what? 1 minus lambda, 0 minus 2, 0. 1 minus lambda minus 2, 0. 0, 0. 1 minus lambda, 0. 0, 0, 0. Minus 1 minus lambda. So we'll take the first column, and the rest will come 1 minus 1. Sorry, this is minus 1 minus lambda. Minus 1 minus lambda minus 1 minus lambda. So it is what? It's lambda minus 1. I take minus minus multiply the square and lambda plus 1 square. So I have lambda minus 1 minus 1 1 1. So I have minus 1 multiplicity 2 and 1 multiplicity 2. Okay, so check how many eigenvectors I will get. For lambda equal minus 1, let V1, K1, K2, K3, K4. Let me try solve the system. See what I will have. 1 minus 1, that will be 2. 0 minus 2, 0. I have 0, 2, minus 2, 0. 0, 0. Minus 1, minus 1, that will be 0, 0. That will be 0, 0, 0, 0. K1, K2, K3, K4. Equal 0, 0, 0, 0. So what I'm getting, 2K1 minus 2K3 equals 0, and K2 minus 2K2 minus 2K3 equals 0. So I have K1 equal K3 and K2 equal K3. Is there any restriction in K4? No. So I have what are the free variables? There will be K3 and K4. So I let K3 be equal 1 and K4 equal 0 and K3 equal 0. Since I have two free variables, what will be K1 will be K2 equal 1. Here I have K1 equal K2 equals 0. So what are the vectors? The vector here will be 1, 1, 1, 0. The vector here will be everything 0 except K4. 0, 0, 0, 1. Okay, now for lambda equals 1, what I will get? Yeah, I let V2 or V3 will be K1, K2, K3, K4. That will give me what? 0, 0, minus 2, 0, 0, 0, minus 2, 0. Then I have 0, 0. This is minus 1, minus 1. That give me minus 2, 0, 0, 0, 0, minus 2. All of this K1, K2, K3, K4. So you have what? Minus 2K3 equals 0 and minus 2K4 equals 0. So implies K3 equal K4 equal 0. Free variables are K1 and K2. There's no restriction in K1 and K2. So I let K1 equal 1, K2 equal 0, K1 equal 0, and K2 equal 1. If I'm doing this, K3 equal K4 always equal 0. So you have V3 will be 1, 0, 0, 0, and V4 will be 0, 1, 0, 0. So A is diagonalizable. And D will be started with 1, with minus 1. So minus 1, 0, 0, 0, 0, minus 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. That will be D. And B, I will stack in vectors 1, 1, 1, 0, 0, 0, 1. And I have 1, 0, 0, 0, 0, 1, 0, 0. This is D and this is P. Okay. Next one. Yeah. We'll do A minus lambda I. That will be what? That will be 1 minus lambda 0, 0, 2, 0, 1 minus lambda 0, 2, 0, 0, 1 minus lambda 2, 0, 0, 0, minus 1 minus lambda, which is very clear. 1 minus lambda cube minus 1 minus lambda. Yeah, equals 0. So the eigenvalues are 1, 1, 1, and minus. Now for lambda equal minus 1, let me go the easy one. Let me make that way. Minus 1, 1, 1, 1. Lambda equal minus 1. What I will get? I let V1, K1, K2, K3, K4. And I solve the system. 1 minus mine, that will be 2, 0, 0, 2, 0, 2, 0, 2, 0, 0, 2, 2, 0, 0, 0, 0. K1, K2, K3, K4. That give me what? 2K1 plus 2K4 equals 0, and 2K2 plus 2K4 equals 0, and 2K3 plus 2K4 equals 0. So I have what? K1 equal minus K4, K2 equal minus K4, K3 equal minus K4. So my K4 is the free variable. So you have K1 equal K2 equal K3 equals minus. So it is my V1. It will be minus 1, minus 1, minus 1, 1. That will be my V1. Now we'll go to the next one. Now for lambda equals 1, I need 3 eigenvectors. Let me see, I will get the eigenvectors or not. K1, K2, K3, K4. Solve the system. I have 0, 0, 0, 2, 0, 0, 0, 2, 0, 0, 0, 2. Then I have 0, 0, 0, minus 1, minus 1, minus 2 times K1, K2, K3, K4 equals 0, 0, 0, 0. So what I have 2K4 equals 0. So K4 equals 0. Okay. What are the free variables? Be careful here. I have K1, K2, K3. I have three free variables, so I let K1 1, K2 0, K3 0. Then I let K1 0, K2 1, and K3 0. Then I let K1 equal 0, K2 equal 0, K3 equal 1. To be sure, I have linear independent eigenvectors. So it will be V2. K4 is always 0, so it will be 1, 0, 0, 0. V3, 0, 1, 0, 0. V4, it will be 0, 0, 1, 0. So I have 4 eigenvectors. So A is diagonalizable. And D will be equal what I start with minus 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. And P, the eigenvectors minus 1, minus 1, minus 1, 1. This is what? 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0. That will be P. Yeah. Good. Next one. I have A minus lambda I. That will be 1 minus lambda 0, 0, 2, 0, 1 minus lambda 2, 0, 0, 0, 1 minus lambda 2, 0, 0, 0, minus 1 minus lambda. We do the calculation. Yeah. So it will be 1 minus lambda, sorry, 1 minus lambda cubed minus 1 minus lambda equals 0. So what are the eigenvalues? Lambda will be equal minus 1, 1, 1, 1. So I need 4 eigenvectors for A to be diagonalizable. Let me see what will happen. I let, no, for lambda equal minus 1. I let V1 to be K1, K2, K3, K4. What will be the system? 1 minus minus 1, that will be 2, 0, 0, 2. That will be 0. 1 minus minus 1, that will be 2, 0, 2. The last one, 0, 0. That will be 2, 2. And that will be 0, 0, 0, 0. Yeah. I have 2, 1 minus minus 1. Times K1, K2, K3, K4 equals 0, 0, 0, 0. So what I have 2K1 plus 2K4 equals 0. So K1 equal minus K4. And 2K2 plus 2K4 equals 0. So K2 equal minus K4. 2K3 plus 2K4 equals 0. So K3 equal minus K4. I will let K4 equal 1. What will be then K1 equal K2 equal K3 equal minus 1. So V1 will be minus 1, minus 1, minus 1, 1. Now for lambda equal 1, I let V2 to be K1, K2, K3, K4, A, B, C, D, and K1, who cares? That would be 0, 0, 0, 2, 0, 0, 2, 0, 0, 0, 0, 2, 0, 0, 0, minus 2 times K1, K2, K3, K4 equals 0, 0, 0, 0. So what I have 2K4 equals 0 and 2K3 equals 0 and minus 2K4, which is equals 0, it's the same. So I have K3 equal K4 equals 0. So what are the free variables? K1 and K2. So I let K1 to be 1 and K2 equals 0 and K1 equals 0 and K2 equal 1. What will be V3? V2, I mean. K3 equal K4 0, the hat will be 1, 0, 0, 0, and V3 will be what? 0, 1, 0, 0. How many eigenvectors we have? We have 3. We don't have 4. We have only 3 eigenvectors. So that means what? A is not diagonalizable. Because I need 4 for A to be diagonalizable. Last one. We have A minus lambda I. That would be 1 minus lambda 1, 0, 1. 0, 1 minus lambda 1, 1. 0, 0, 2 minus lambda 1. 0, 0, 2 0, 2 minus lambda. Yeah, if we do the calculation, that will be what? 1 minus lambda square, 2 minus lambda square equals 0. So lambda will be 1, 1, 2, 2. Now for lambda equal 1, we have what? Let B1, K1, K2, K3, K4. So I have what? 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1. Yeah. And I have 0, 0, 0, 1 times K1, K2, K3, K4 equals 0, 0, 0, 0. What will happen in this case? We have K2 plus K4 equals 0, and K3 plus K4 equals 0, and K4 equals 0. Plug it here. So I have K3 equals 0 there. So K2 equals 0. So the free variable only K1. So V1 will be 1, 0, 0, 0. So for sure A is not diagonalizable. But let me to be sure more, let me do the other one. So for lambda equal 2, for lambda equal 2, I'm expecting at most 2 eigenvectors. So it will be 3. So A is not diagonalizable, but for completion, let me do lambda equal 2. See what will happen. I let B2, K1, K2, K3, K4. So that give me what? Minus 1, 1, 0, 1, 0, minus 1, 1, 1, 0, 0, 0, 1, 0, 0, 0, 0 times K1, K2, K3, K4, 0, 0, 0, 0. Let me see what will happen. I have minus K1 plus K2 plus K4 equals 0, minus K2 plus K4 equals 0. I have minus K2 plus K3 plus K4 equals 0. The last one, K4 equals 0. If K4 equals 0, plug it here. So I have what? Yeah, I have minus K1, or let me say, this will be 0. This will be 0. So I have what? K2 will be equal to K1, or let me see, K1 equal K2 from here. And from this, I have K3 equal K2. So I have my free variables is K2. So let K2 will be equal to 1. You will get K1 equal K3 equal 1. So it will be V2 will be 1, 1, 1, and K4 is 0. So we have only 2 eigenvectors. We have only 2 eigenvectors. So that means A is not diagonalizable. Yeah. That's it. Yeah, I think that will be the last one. So let me stop the recording. That will finish section 6.2. And I think also it will finish the material needed for the second exam. So I will stop the recording now. Thank you.